Okay, so in this lesson, we're going to talk about inverse functions. All right, so an inverse function is a function that will undo. Notice I have in quotation marks, undo anything that an original function does. All right, so an inverse function undoes anything that a function did. Okay, so let's just talk about some examples of inverse functions, something that you would do every day. So we all have a way of tying our shoes, and how we tie our shoes could be called a function. So what would be the inverse function of tying our shoes? Well, the inverse function would be untying our shoes, because untying our shoes will undo the original function of tying our shoes. So if we tie our shoes, untying would undo what we did. Okay, so another example would be um, when someone calls you on the phone, he or she looks up your number, and so the function would be from names to phone number. When caller ID shows you who is calling, it has performed the inverse function. And so the inverse function would be finding the name that corresponds to the number. So when someone calls you, um, they look up your name, and then they get a phone number. Caller ID will look at the phone number and get the name. And so that's the name that shows up on caller ID. Okay, so in terms of a more mathematical example, something that you've dealt with probably in middle school, is the idea of converting from Fahrenheit to Celsius and from Celsius to Fahrenheit. So those would be considered inverse functions. So when you so if you look at the function that converts temperature from from Celsius to Fahrenheit, that function that converts that temperature, then the inverse function would be the opposite, would be converting Fahrenheit to Celsius. So if you look at the formulas for those two, so let's suppose we look at this. So um, the formula, so the formula for converting Fahrenheit to Celsius, I'm sorry, converting Celsius to Fahrenheit, you're trying to find Fahrenheit, is this, 9/5 C plus 32. So there's your function. So that's a function that converts Celsius. So if you have a Celsius temperature, you multiply by 9/5, add 32, and then that gives you your function. The Celsius conversion, so if you want to find a Celsius temperature given the Fahrenheit, it would be, um, it would be 5/9 times the Fahrenheit temperature minus 32. All right, so that will be your function there. So those are inverse of each other. So this function is the inverse of that function. That function is the inverse of that function. Okay, now we're going to talk more about functions because we really want to use function notation like f of x, g of x, and so on at some point. But let's look at another numerical mathematical example. All right, suppose we have the function f of x equals 2x minus 5. So we have that function. So f of x equals 2x minus 5. Now this function says this. This function says that I can take any value for x. Any value for x. So for example, remember f of x here means the same thing as y. So I can take any value for x, let's say 2, and plug it into this function f of x. So what would happen to x? I'm sorry, what would happen to 2, or this x value 2? So if I plug in 2 here, notice what happens. I am multiplying by 2, and then I am subtracting 5. Okay, so first, the value of x, whatever I'm substituting, the value of x would be multiplied by 2. So remember the order of operations. It would be multiplied by 2, and then you would subtract 5. All right, and so that would give us negative 1. So again, if I do, let's say 4, so let's say I'm substituting 4, you would say 2 times 4, so you're multiplying. So this function multiplies the value of x by 2 and then subtracts. So you get 2 times 4, subtract 5. So that's 8 subtract 5, which is 3. So regardless of how many examples you use here, notice that the function f, the operations that's being performed is multiplication. That's the first thing you do first is multiplication, and then you subtract 5. So subtraction will be done next. Okay? Now, so the two mathematical operations that this function does is multiplication and subtraction. So this function, the mathematical operations are multiplication and subtraction. So the mathematical operations are multiplication and subtraction. Okay. Now, let's talk about the inverse function. So remember, the inverse function undoes what the original function does, or did. All right, so in this case, if my function had the operations multiplication and subtraction, then I've got to do what this function did. So if this function f of x subtracted 5, then the inverse function has to add 5. If this function multiplied the variable x by 2, then the inverse function has to divide by 2. All right, so if my original function, the operations involved were multiplication and subtraction, then the inverse function does the opposite. The operations involved are, so the inverse operation multiplication is division, and the inverse operation subtraction is addition. Okay? So let's kind of look at this statement again. So remember, we looked at this function right here, f of x equals 2x minus 5. And so if we take any value of x and plug into the function f, then what would happen? Well, first of all, the value of x will be multiplied by 2. So we've had experience with that. And then subtracting 5. So remember, when you graph lines, this is a linear function. When you graph the linear function, you would get 2 points. So you just substitute value for x, and then find out what this y value is. All right, so it would multiply by 2, and then you would subtract by 5. The two mathematical operations that are taking place in the function f of x are multiplication and subtraction. Now, if you consider the inverse function, what two mathematical operations would be needed to undo what this function did? Well, to undo what this function did, you would use the operations of addition and division. So the opposite operations. Okay? All right. Now, what I want to do next is kind of talk about how to get that inverse function. Now, there is a procedure for getting the inverse function. We're going to talk about that in a little while. But let's just kind of figure out ourselves how to find the inverse function of f of x. And before I go on, let's just kind of do a few more examples here, because we're going to need this table at some point. So if x is, let's say, 0, 2 times 0 is 0. 0 minus 5 is negative 5. If x is, I'm just picking some numbers for x. Remember, the domain here is all real numbers, so I can use any number for x. If x is, let's say, negative 1, I get 2 times a negative 1, which is negative 2. And negative 2 to negative 5 is a negative 6. If x is, let's say, a negative 2, I get 2 times a negative 2 is a negative 4. A negative 4 to negative 5 is a negative 9. Okay? All right. So remember, I'm trying to find the inverse function. So the inverse function undoes what this function does. So remember, if I substitute 2 into this function, I get negative 1 as my value. Okay, so I want to undo this. So basically what I want to do is at some point go from a negative 1 to a 2. So it undoes what happened here. So I went from a 2 to a negative 1. I went from a 4 to a 3. I went from a 0 to negative 5. I went from negative 1 to negative 6, and went from negative 2 to negative 9. So I want to undo what just happened. So if you undo what just happens, you want to go from negative 1 to 2, from 3 to 4, from negative 5 to 0, from negative 6 to negative 1, from negative 9 to negative 2. That's what you want to do. So that's what an inverse function does. It undoes what you just did. Okay? So if we look at this function here, this explicit function, so I'm going to go ahead and rewrite it again. F of x equals 2x minus 5. All right, so if I look at that, now I'm going to go ahead and replace f of x with y, because remember that we can think of it that way as well. So y equals 2x minus 5. All right, so what I want to do is undo what just happened. Okay, now you see right here, that's subtracting 5. So remember, we can add 5 to both sides. Now I would not do division yet, because then you would have a fraction. You'd have y divided by 2, negative 5 divided by 2, and this would be x. So let's just do the division last. All right, so I'm going to add 2 to both sides. I'm sorry, add 5 to both sides. So notice what happens. I'm adding 5, so I get y plus 5 equals 2x. And then I'm going to divide both sides by 2, and so I get x equals y plus 5 divided by 2. Now, when we talk about the procedure, you're going to notice that when we do the procedure, we're going to do this a little bit differently. But right now, I just want to talk about this inverse operation. So this function f multiplies by 2 and subtracts 5. What I want to do is the opposite. So I'm going to add 5 and then divide by 2. Now this right here, this function right here, is considered the inverse function. That's your inverse function. So in other words, remember how a while ago when we said that f of x takes 2 to negative 1, 4 to 3, 0 negative 5, negative 1 to negative 6, negative 2 to negative 9? The inverse function does the opposite. It takes negative 1 to 2, 3 to 4, negative 5 to 0, and so on. So if I substitute, I want you to see this. I'm going to call this inverse function g of x, which means this now. Okay, so listen carefully. So which means that if I call this g of x, now there is a certain notation we're going to use in a little while to show you what the notation is, but since we haven't talked about it at this point, and you do understand the function notation f of x, g of x, h of x, then let's use that. So I'm going to call this function right here, just look at this right now. This is going to be g of x, but then I got to replace the y with x. So my g of x is going to equal x plus 5 divided by 2. Okay? So now I want you to notice this. If I let x be negative 1, if I let x be negative 1, notice what happens. Negative 1 plus 5 is negative 4. Negative 1 plus 5 is positive 4 divided by 2 gives me 2. If I take 3, if I let x be 3, then I get 3 plus 5 divided by 2 is 8 divided by 2, which is 4. So I get the 0.34. If I let x be negative 5, I get negative 5 plus 5 divided by 2, which is 0 divided by 2, which is 0. If I let x equal negative 6, I get negative 6 plus 5 divided by 2, which is, oops, did I say negative 6? All right, yeah, so let's do negative 7. I'm sorry, because I didn't want to use a fraction. So negative 7. So negative 7 plus 5 divided by 2 is negative 2 divided by 2, which is negative 1. Okay, and then if I do negative 9, I get negative 9 plus 5 divided by 2 which is negative 4 divided by 2, which is negative 2. Okay? All right, now I want you to notice something. I want you to compare this inverse function, g of x, with the original function, f of x. All right, I want you to compare the table. Now, I did make a mistake here. Remember a while ago I said negative 1 goes to negative 6? Well, that was a mistake because 2 times negative 1 is negative 2. A negative 2 and a negative 5 is a negative 7. So I did make that change. So make sure you understand that. So that should be negative 7. Now, I want you to compare this table. A while ago we said this. We said that f of x, when I plug in 2, I get negative 1. When I substitute 4 into x, I get 3. When I substitute 0 to x, my function, and this function f of x, I get negative 5 and so on. Look at the inverse function, what it did. Look, compare those two tables. Let's see. Let me go ahead and do this. All right, so to compare those two tables, right here, notice when x is 2, y is negative 1. This time when x is negative 1, y is 2. 4, 3 became 3, 4. 0, negative 5 became negative 5, 0. Negative 1, negative 7 became negative 7, negative 1. Negative 2, negative 9 became negative 9, negative 2. So notice that, and I'm going to go ahead and write it horizontally like this. I just want you, so I can show you this. So this was f of x, which is y. So 2, negative 1, 4, 3, 0, negative 5, negative 1, negative 7, negative 2, negative 9, and that was f of x equal 2x minus 5. Over here, okay, remember this time my inverse function was this, and it turned out to be x plus 5 divided by 2, which kind of makes sense because remember, inverse function undoes. So if this is subtracted, this inverse function better add. If this divided, multiply, then this better divide. Okay? But I want you to notice that as we substituted these y values, as these y values became my x's here, so remember we're trying to undo what this function did. So if this function brought 2 to negative 1, then it's got to undo it. So it's got to bring negative 1 back to 2. So hence, negative 1 returned back to 2. 3, right here, returned back to 4. And so on. So negative 5. In my inverse function, I got 0 back. When I substitute negative 7, I got negative 1 back. And when I substitute negative 9, I got negative 2 back. So I want you to notice that when you're dealing with inverse functions, and this idea is going to be important in a little while, my y-coordinate here in the original function became the x-coordinate in the inverse function. The x-coordinate in the original function became the y-coordinate in the inverse function. So x becomes y, y becomes x. So x becomes y, y becomes x. All right, so you're gonna learn that and hopefully understand a little bit more as we go through this. I want you to notice something though. If I graph these two functions, f of x and its inverse, and we haven't talked about the notation for inverse yet, but if we graph these two, I want you to notice something. So I'm going to graph, and remember these are both of those are linear functions, so those are going to be lines. So let's go ahead and graph f of x. So f of x, I'm just going to plot those points, and I just need 2 points, but I'm going to use all of them just so I can make a comparison again. So, but all you need are 2 points to graph a line. So 2, negative 1 is here. 2, negative 1 is right here. This 4, 3 is right here. 0, negative 5 is right here. Negative 1, negative 7 is right here. And a negative 2, negative 9 is right here. All right, so if I draw that line, and I'm going to go ahead and use a red line here. So if I draw that line, I get this. So I get this line right here. So that's the function f of x. So that is f of x right here. And remember, f of x was 2x minus 5. Now, let's go ahead and graph the function g of x. See what that looks like. So if I graph the function g of x, here are my points for g of x that I'm going to use. And remember, these are lines. You just need 2 points. You just need 2 points. But I'm going to go ahead and plot all 5 points here. So I'm going to plot the point negative 1, 2. So negative 1, 2 is here. 3, 4 is here. Negative 5, 0. Negative 5, 0 is here. Negative 7, negative 1. Negative 7, negative 1 is here. Right here. Negative 9, negative 2. Negative 9, negative 2 is right here. All right, now I'm going to use a purple line for this one. And I'm going to draw this line. All right, so I get something that's going to look like this. I'll do the best I can with connecting these points. So I get something that looks like this. I'm going to go ahead and extend the red one again. All right, so I'm going to extend this one. All right, so remember this was a function, this purple one was a function g of x equal x plus 5 divided by 2. All right, now you remember we discussed, I want you to look at those, at these points here. This point here, remember, was 4, 3. This point here is 3, 4. Okay? This point here was 2, negative 1. Remember we talked about, so if the point 2, negative 1 was on the function f of x, then what other point is going to be on the inverse? Well, the inverse is going to be negative 1, 2, so it undoes. So if x is 2 and I get y, then the inverse function will undo it. So negative 1 will become 2. So negative 1, 2 is here. Negative 1, 2. Over here, if this is a point 0, negative 5, then what other point better be on the inverse? So if this is on the function f of x, then the point on the inverse better be negative 5, 0. Negative 5, 0. And it is right here. This point here on f of x is negative 1, negative 6. Oops. Yep, negative 6. On f of x, was it? No, I'm sorry, that's negative 7. Okay, negative 7. Then the other point better be negative 7, negative 1 on the inverse. And it is. So negative 7, negative 1. Okay? Now, I want you to notice something. Those two graphs. Now, remember a while ago we said that the x becomes y and the y became x? So look, x right here became the y value, and this y value became the x value. This x value became the y value, and this y value became the x value. So y became x and x became y when you look at the inverse functions. So what I want to do now is I want to graph the line y equals x. Since we just said this x value became the y value, so x equals y, and this y value became the x value, y equal x, or x equal y. Okay, so I'm going to go ahead and graph that one. So if I graph this line right here, what that means is this. Just going to pick about 2 points to graph this line. If x is 0, then y is 0. If x is, let's say, 2, then y equals 2. So that means, notice what that means. That means that y and x are always the same thing. So that means that whatever values in this x column, I'm going to get the same values in the y column. So if x is 3, y is 3. That's what it says. Y and x have to be the same number. If x is negative 1, y is negative 1. If x is negative 2, y is negative 2. All right, now if I plot those points, I'm just going to do 2 of them. So the origin, 0, 0 is the origin. and 2, 2 is right here. All right, so if I plot those points and draw the line, and I need to do as best job I can with doing this. Maybe I need to do one more. So if x is -1, y is -1, -1, -1. So let's say here. All right, so I'm going to use a pink color here. Well, let's do blue color, light blue, and I get this. So this is the line y equals x right here. So I want you to notice the idea of symmetry. The idea of symmetry. Remember we talked about symmetry in previous lessons. The orange graph, or the red graph here, f of x, is symmetric about the line y equals x. So when I use the idea of symmetry, I get this line back. Okay, so just think of symmetry. So this red line right here is symmetrical about the line y equals x. So those two graphs are symmetrical about this line. So if I use symmetry on this purple one, symmetric about this line y equals x, I get this red one. Okay? All right, so basically, here's the idea though. So let's see, I'm going to go ahead and use a pink one here. Okay, so all right, so if I take those 2 points right here and this point, they're inverses of each other, and if I connect those 2 points, right here, and do the same thing with these two, and then do the same thing with these two, and do the same thing with these two, and so on, I want you to notice something. So remember when we talk about symmetry about a line, the distances are the same. So in other words, if I take this distance from this point to the line of symmetry, remember saying the line of symmetry for inverse functions is y equals x, and I look at that distance here, that distance better be the same, and it is. If I look at the distance from this point to the line of symmetry, then that should be the same as this distance here, and it is. Okay? All right, so that's why you notice that these two lines, f of x and g of x, they're symmetrical about the line y equals x because those distances, this distance and this distance are the same. That distance and that distance are the same, and so on. So just like when we talked about symmetry about the x-axis, about the y-axis, about the origin, and so on. The same thing here. That symmetry, the idea of symmetry applies. Okay, now I want you to notice something though, and this is going to be important. I'm going to go ahead and write it here. So I want you to notice this, based on what we just talked about. So inverse functions, f of x and g of x are inverse functions. They undo each other. Okay? Inverse functions are symmetrical about the line y equals x. So inverse functions are symmetrical about the line y equals x. Just like we remember we talked about even functions, we said even functions were symmetrical about the y-axis, same idea. Odd functions were symmetrical about the origin, same idea. Inverse functions are symmetrical about the line y equals x. Okay, so several things you got to remember about functions. Even functions, what about their symmetry? Odd functions, what about their symmetry? Inverse functions, what about their symmetry? Well, inverse functions are symmetrical about the line y equals x. All right. Okay, now one other thing we need to remember about certain things about inverse functions. Okay, so we're now going to talk about inverse function notation. All right, and it's not that difficult. It's just a different way of writing. Instead of saying g of x to represent the inverse function of this function here, we prefer to use a different notation. Now, there's a lot of rain on the outside from the tropical storm, so I'll do the best I can with the audio on this. All right, so let's talk about function notation. So listen carefully to this. Remember a while ago we said this. We said that f of x, which equals 2x minus 5, was my original function. The inverse function of f of x, and we said was this, is g of x, which we call g of x, is x plus 5 divided by 2. All right, now let's talk about notation for inverse. Okay, so if f of x represents, if f of x represents a function, if f of x represents a function, then the notation, and here's the notation. I'm going to go ahead and write it out first. Okay, this notation that I just wrote. All right, now this notation is read f inverse of x. That's how you read that notation. All right, now let's be clear. This does not mean f to the negative 1 power. Okay, that's not what that means. That does not mean f to the negative 1 power. This does not mean, this is not f to the negative 1 power. That's not what that means. Okay, that's not what that means. So be a little bit careful. Don't think of this as something you've had in the past. Like, for example, 4 to the negative 1 power. And remember, 4 to the negative 1 power means 1 over 4. 3 to negative, let's say, 4th power means 1 over 3 to the 4th. 2/3 to the negative 1 power means, let me do squared, negative 2. So 2/3 negative second power is 3/2 to the second power. All right, so this idea, those are exponents here. All these are exponents. This is not an exponent. That's just a notation. So when you see a function like f of x and there's a negative 1 that looks like it's an exponent, that's not an exponent. That just means f inverse of x. That's how you read it. F inverse. So this negative 1 is not a power. It just means an inverse. All right, so don't confuse that with this. So this means f inverse of x. Okay? So this notation will be used to denote the inverse of f of x. Denote the inverse of f of x. All right, so again, that's not f negative 1 power. That means f inverse. This means exponents 4 to the negative 1 power, 3 to the negative 4 power, 2/3 negative second power, and so on. Okay? And so remember, you don't always have to use f inverse of x. You could use different function names. So in other words, similarly, the notation g inverse of x. Remember this notation right here. Again, when you have function notation, this does not mean a negative 1 power. Is read g inverse of x. Okay? All right, and that's going to be used to denote the inverse of x. So this will be used to denote the inverse of g of x. Okay? All right, so let's go back to this right here now. We're going to go back to this. So if f of x is 2x minus 5, if f of x is 2x minus 5, I'm going to write it right here, then f inverse of x, all right, so then f inverse of x is going to equal, remember we already found the inverse, remember this was the inverse right here, x plus 5 divided by 2. So instead of saying g of x, though, we're going to call it f inverse of x. So f inverse of x will be x plus 5 divided by 2. All right, and so when we did the graph a while ago, we did this graph, I could now call, if this is, remember this was f of x, then I'm going to call this one f inverse of x. Okay, f negative 1, which means inverse. All right, so f inverse of x. Okay, now let's look at another example. Let's do one more example. I'm going to use a line. We're only going to be dealing mostly with lines here, and just finding that inverse, and then we're going to graph it. Okay, so let's look at this example. Suppose you're told that g of x, I'm using different notation, g of x this time, is, let's say, negative 3x, let's do positive 3x, positive 3x plus 2, positive 3x plus 2, so 3x plus 2, that's g of x. And I ask you to find the inverse. Find the inverse, okay? All right, now, find the inverse of g of x, Okay, so a couple of things. This is linear, so it's not that difficult to be able to do what we did earlier in terms of the inverse operations. So notice that g of x, whatever x value I use, it multiplies it by 3, and then it adds 2. So think about the inverse. So if g of x involves multiplication and addition, then the inverse is going to involve subtraction and division this time. Okay, subtraction and division. Okay, so now keep in mind that the inverse of g of x is going to be denoted like this. Okay, so in other words, you want to find, i.e., you want to find g inverse of x. You want to find that. That's what you want to find. All right, now we're going to do it. Now there is a procedure you're going to use. We're going to talk about it in the next lesson. So this is just part 1, just getting a basic understanding of inverses. But think about what we did earlier when we did this right here. When we did this function, we got this. All right, let's use that idea. Okay, so remember g of x means the same thing as y, so I'm going to put this as y right now. So y, right now I have y equals 3x plus 2. And so let's just get x by itself. So remember the inverse will undo the addition. So instead of adding 2, I'm going to subtract 2. And so I get y minus 2 equal 3x. And then I'm going to divide both sides by 3. All right, and so I get x back. So I went from plugging in for x and getting y, and now I'm going to plug in for y and get x back. Okay? So I get y minus 2 divided by 3 equals x. This right here is my inverse. So that's going to be g inverse of x. So this is your inverse. But when you write it, though, make sure, you see how I'm using x here? Make sure you replace that y with x. So my inverse then will be x minus 2 divided by 3. So that's your inverse. Okay, x minus 2 divided by 3. And let's just check this. Let's just see if it is correct. And now, on a test, you're not going to have time to do that, but we can do that here. So here's my function g of x, which is 3x plus 2. And I'm saying that my inverse, the inverse of g of x, is x minus 2 divided by 3. That's what I'm saying. So let's do a few points here, and let's see what we get. Okay, so when x is, let's say, 0, I get 3 times 0 plus 2, which is 2. And then over here, let's just check it. When x is, remember, these are inverses, so 0 becomes 2. 2 better become what here? 0. Let's check. 2 minus 2 is 0. 0 divided by 3 is 0. So 2 minus 2 is 0. 0 divided by 3 is 0. And that's what I get. Over here, if x is 1, 3 times 1 is 3. 3 plus 2 is 5. Oh, so over here, remember, the inverse undoes it. So if I start with 1 and get 5, then I want to undo it. So I want to go from 5 to 1. That's what I want to do. And so let's check. 5 minus 2 divided by 3. 5 minus 2 is 3. 3 divided by 3 is 1. And so I get that back. If x is, let's say, negative 1, 3 times negative 1 is a negative 3. Negative 3 plus 2 is negative 1. So over here, I better get negative 1, negative 1. Let's see. Negative 1 subtract 2 is negative 3. Negative 3 divided by 3 is negative 1. I get that. Let's do one more. So based on what you notice that x becomes y becomes x. Okay? If x, let's say, is negative 3, I get 3 times negative 3 is a negative 9. Negative 9 plus 2 is a negative 7. So over here, I better get a negative 7, negative 3. So let's see. Negative 7 subtract 2 divided by 3. So that's negative 9 divided by 3, which is negative 3. All right, so that's what I get. So if I were to graph this, if I were to graph g and its inverse in a coordinate plane, remember they're going to be symmetrical about what line? They're going to be symmetrical about the line y equals x. All right, so let's look at that. Let's just do that real quick. Okay, so let's plot the point. I'm going to go ahead and graph g of x. So g of x, these are the points I'm going to plot. So 0, 2 is here. 1, 5 is here. Negative 1 is here. And then negative 3, negative 7 is here. Negative 3, negative 7. All right, and so if I plot that point, if I graph that line, I get this. So this is g of x, g of x that I'm graphing right here. All right, now let's graph the inverse. So the inverse, let me go ahead and say this was g of x, which is 3x plus 2. All right, now let's graph the inverse. So the inverse, here are my points that I'm going to use now. Although, remember, we know that the x and y's are inverted. So if you know that this right here, is a point 1, 5. So if 1, 5, listen to the words. If 1, 5 is on g of x, then what point is going to be on its inverse, on the inverse function? So if 1, 5 is on g of x, then 5, 1 is going to be on the inverse. So 5, 1, plot the point 5, 1. If the point 0, 2 is on g of x, then what point is going to be on g inverse, the inverse of g? 2, 0. 2, 0. This point here is negative 1, negative 1. So if the point negative 1 is on g of x, then what point is going to be the inverse? Well, the point negative 1 is going to be in the inverse, which is that same point right here. Over here, this point is, let's see, that was negative 3, negative 7. Then what point is going to be in the right here? What point is going to be the inverse? Negative 7, negative 3. So negative 7, negative 3 is right here. And so if I draw that line using the purple color this time, I get this. All right, and that is G inverse right here. So that's G inverse, which is x minus 2 divided by 3. All right, now remember we said this. We said that G in G inverse, we said that the inverses, if two functions are inverses of each other, and they are, you can tell, multiply by 3, add 2, divide by 3, subtract 2. So subtract 2, divide by 3. They are symmetrical about what line? So remember, let me go ahead and show you. So this was the 0.51 here. So This y value became this x value. This x value became this y value. 0, 2 became 2, 0. So this y value became this x value. This x value became this y value. Over here, that was -7, -3. So -7, -3 became -3, 7. So this y value became so this y value became this x value, and this x value became this y value. Okay? So y equals x, basically. So y becomes x, x becomes y. So that means that those two functions are symmetrical about the line y equal x. So y equal x, remember, y equal x means that whatever x value you choose, is the y is going to be the same value. So if x is 0, y is 0. If x is 2, y is 2. If x is 3, y is 3. If x is -1, y is -1, and so on. Okay, so 2, 2, -4, -4. I'm just picking some points here. 5, 5, 5, 5. So basically all these points, the x and the y, are the same coordinate. And so notice that y equal x, by the way, goes through the first quadrant and the second and the third quadrant. Notice goes through the first quadrant and third quadrant, right in the middle. See, it intersects, or it cuts the quadrants in half. See this? Okay. Same thing here. And so when I graph it, I do want you to notice something. I'm going to graph this. So here's the line y equal x. That's the line y equal x. Notice that those two functions, g of x and g inverse, are symmetrical about that line. Because, and then remember the idea of distances. So if you look at those 2 points that are inverse of each other, that distance is the same as that distance. That distance same as that distance. This distance same as this distance, and so on. Okay? All right, so that's going to take care of part 1 of this lesson. This is a basic introduction to what inverses are and what their graphs look like. What does it mean for the points involved and the inverse functions. Okay? In the next part of the lesson, we're going to answer the question, and this is going to be important. We're going to answer the question, do all functions have an inverse? Do all functions have an inverse? So that's going to be the next part of your lesson dealing with inverse functions. So basically, question which we're going to answer, do all functions have an inverse? So there are quite a few things that we're going to have to discuss in order to answer that question. But for right now, for these lines do have an inverse, and so you notice that they were symmetrical about the line y equal x. Okay? All right, so I'll take care of this part of the lesson.